Okay, good afternoon, and thank you for staying on for the closing session. As the session says, we are now nearing the end of the conference. There is a slight change in the program. We will start with the awards, then the lecture by Professor Reklaitis, then the presentations by the two future conferences, and then we finish. And then there will be coffee, tea in the foyer, not in Hall A. So the program is, we will give the poster awards, then the EFCE award, and then the Roger Sargent Medal. Then, as I said, Professor Reklaitis will talk about highlights and new directions for PSE, and the two future conference presentations, ESCAPE25 and PSE 2018. So we will start with the poster awards, and this will be 3 awards for the best posters on Monday, Tuesday, and Wednesday. And these were selected by the panel that was mentioned in the technical program. So I thank all the panel members. They did a great job looking through almost 100 posters every afternoon and coming up with their selections. So the first winner, I hope the winners are here, is Torben Egger and George Fig. The paper is Modeling and Simulation of an Enzymatic Catalyzed Reactive Dividing Wall Column, poster P126. Any of the authors here present? Okay. But we will send this to them. There is one other advantage that they will get, but I will tell you for the next winner. And I'm sure the next winner is here. This is, now I don't know whether it's Imperial College or Texas A&M, but it's Amit Jubeda and Stratos Pistikopoulos. Please, if one or all of you are here. Okay.
It's good to get an award regardless destination. So.
The certificates are for all 3 authors, and now I will tell you the secret. I made a deal with ESCAPE25 that one of the authors will get a 50% discount.
Okay. Not me, not me.
And the third winner, I think I had seen him in the last keynote session, so I hope he's here, is the paper from Canada. Noor Haroon, David Tucker, Thomas Adams II. So,
thanks.
And one of you also will get 50% discount at ESCAPE25. Yeah. Okay, so now we come to the next award winner, and this is the EFCE Lifetime Achievement Award. And I would like my colleague, Jean-Marc Leland, he's the scientific vice president. He will make the announcement.
So, ladies and gentlemen, dear colleagues, it's a great pleasure and an honor to me to ask Professor Reklaitis to come there. And under the behalf of EFCE, I am the honor to give you the 2015 EFC Lifetime Achievement Awards in recognition of the role you play for more than 40 years as representative of the Czech and Hungarian EFC member societies, as an active member and a chairman and new refreshed chairman from the CAPE Working Party from EFCE. And also these awards, it's acknowledge all the substantial service to chemical engineering education and qualification, and also to your research achievement and very heavy contribution to the organization of numerous meetings, workshops, and courses related to CAPE, related to process integration and modeling, related to sustainability, including the famous ESCAPE and Press series events. So, Jerry, it's a very great pleasure that Professor Gay and myself.
That's the award. You can give the name. Okay. So, congratulations.
Thank you very much indeed. I deeply appreciate the award from European Federation of Chemical Engineering. As Professor Gani said and Professor Lanan, I've been around quite a long time. You know, it doesn't look so, but if I remember, pre-ESCAPE conferences, ESCAPE conferences. Well, ESCAPE conference is 25 years old, which is, as I said at the opening, the best age. I'm a little bit older, but still ready to do whatever I can for European Federation of Chemical Engineering and for the Working Party, CAPE Working Party, Process Intensification Working Party, and also for sustainability. Thank you very much indeed.
Thank you. And the last award to be given now is the Roger Sargent Medal. This is awarded to one or more individuals who have made a significant recent contribution to the research into computer-aided product and process engineering. The contribution could encompass, but need not be limited to, a concept that has promoted much interest, the solution of an unsolved problem, new methods, tools leading to innovative processes, products, or a significant advance of the state of the art within the process systems engineering. The Sargent Medal is initiated by IChemE of UK, and a panel of members were selected as the selection committee to decide about the award. The process was an open nomination, and based on the nomination, the panel members decided. I would like the panel members who are here to also come, please. And there is one panel member who was at the conference, but he had to go back. That is Professor Mannan from Malaysia. And we all unanimously agreed that Professor Ignacio Grossman from Carnegie Mellon University is the first winner of the Roger Sargent Medal. Please, Ignacio. And there is a nice certificate from the IChemE and a real medal also made by the IChemE. Thank you very much. Please.
All right. Really, thank you so much first to the Institute of Chemical Engineers for this great distinction. It is truly a great distinction and an honor for me to be the recipient of the Roger Sargent Medal. And the main reason is because of the great admiration and respect I do have for Professor Roger Sargent. As you all know, Professor Sargent can really be considered to be the founder of the area of process systems engineering. In fact, he has been the intellectual leader of the area. He's the one who has provided, if you wish, a strong foundation, especially mathematical foundation, to process systems engineering. In fact, I think we could also say that one of the reasons we're celebrating this PSE and ESCAPE meeting is because of him, because he's the one who really has founded the area. He has obviously made tremendous contributions, and one of the examples to see the kind of contribution he has made is if you look at his academic tree. Many of you, I'm sure, know about the academic Sargent tree, and I thought it would be interesting to try to estimate how many of the participants at this meeting belong to the academic Sargent tree. I couldn't quite come with a number, but I could come up with some lower and upper bounds. So my estimate, the lower bound is 20%, the upper bound is 40%. But needless to say, the tremendous has been absolutely tremendous. And I have been really, truly fortunate to have had Professor Sargent also as a mentor. He was my advisor. He was the one who really inspired me to, work in this area and set very high standards of quality and innovation. So I'm really most grateful to be with again to Professor Sargent. I'd also like to take the opportunity here to thank first my graduate students. I think one of the reasons I'm here is, of course, because of all the hard work that my graduate students have made and the excellent contributions that they have made in the area. I'm also very grateful to many of the collaborators that I've had throughout the world with whom we have shared, research experiences. I'm also very grateful to my colleagues at Carnegie Mellon who have provided a very stimulating environment. Also very thankful to the process systems community at large. I really thank the friendship, the support that I have received from all of you. But I also have to thank very much my wife, Blanca. I think if I'm here, it's really because of her. Without her, I would simply not be receiving this award. So again, in closing, needless to say, this award, of course, means a lot to me. I was extremely thrilled when I found out that I was made the recipient of this award. And again, I would like to thank very much the ICME. I would like to thank very much the committee for receiving this award, because I could also say that perhaps this is the most important award that I have received in my academic career. Thank you. Thank you.
And this. Okay, so before I go to the next event, I just remembered that I forgot to mention that all these nice certificates are made by Elsevier because the poster sessions were sponsored by Elsevier. Please. So next we move on to the final lecture of this conference, except for the two presentations afterwards. This lecture is going to be given by Professor Reklaitis, and Rex is Burton and Catherine Gage, Distinguished Professor of Chemical Engineering at Purdue University and Deputy Director of the NSF Engineering Research Center on Structured Organic Particulate Systems. At Purdue, he has served as the head of School of Chemical Engineering and director of the Computer Integrated Process Operations Center. His expertise lies in process systems engineering, the application of information and computing technologies to process and product design, process operations, supply and supply chain management. current research. I think all of you know Rex very well, so I will not read out all these things, but he's a member of the U.S. National Academy of Engineering, a fellow of AICHE, and past editor-in-chief of Computers and Chemical Engineering. He has received a lot of awards. I will not list them now. He has served on the board of directors of AICHE, the Council of Chemical Research, and the Cash Corporation. He has published over 200 papers and book chapters and authored 8 books. I would invite Rex to give his talk on highlights and new directions for PSE.
Thank you. So thank you very much for the introduction and for the opportunity to chase everyone off the conference site. As Rafik pointed out, I'm supposed to have a dual assignment, is to first highlight some of the things that you heard or should have heard if you had been able to attend all the sessions, and then secondly to draw on your collective wisdom to try to focus on what are, based on our current directions, what are really exciting new things for us to look at in the future. So that's the objective, and so my outline is really very straightforward. I will briefly touch on PSE and its traditional scope, then taking that as a template, try to map what was the scope of what we experienced this week and how does that match with that traditional scope, how does it enhance it. Then I would like to point out some areas of special interest, focusing on specific papers. And finally, say the new directions part. So that's the agenda. And just to start it off, I thought I would borrow from a definition of process systems engineering that George Stephanopoulos cooked up some years ago, which is pretty concise. And it says it's the engineering of systems involving physical, chemical, and biological processing operations, where the key words really are engineering and systems, and of course, the processing as well, because that really is the domain within which we apply our systems engineering concepts. Now, excuse me, the traditional processing systems that our community has focused on in over 50 years have included, of course, chemicals and materials for society's wants, fuels and energy from fossil and non-fossil sources, quality of water in the environment, diagnostics and therapies for treatment of disease, and of course consumer goods to enhance quality of life. Now, given this broad categorization of sort of things we've worked at over the past 50 years, what has happened? What have we talked about at this conference? I've put together a couple of shopping lists, and I won't read all of them to you, but they indeed do cover the range of topics that we've talked about. It certainly both includes things that have been treated in the past few years, but also I view as kind of a renaissance of process engineering. We've really covered such a broad spectrum of processing operations, and particularly I think in this meeting, this broad spectrum was particularly notable because it was pursued by all 3 geographic areas where PSE is practiced. Lots of contributions from Asia, lots of contributions from the Americas, and substantial contributions from Europe as well. And of course, some of these areas have more recent focus. Certainly the biomass arena as a source for chemicals is really a topic of the last few years. Carbon capture is a topic of the last few years. The notion of actually doing something with CO2 other than stuffing it into the ground is a relatively new focus for our community. Renewable energy systems in general, actually a few years ago, it would have been inconceivable that the chemical engineers could have, courageously marched into telling the world how to handle electric power systems, but we're doing that with great vigor. Certainly, those of you that attended the keynote session just a little while ago saw some interesting presentations in looking at human physiology and treatment of disease in general. The notion of pharmaceutical engineering, of pharmaceutical products and processes, we've looked at that over the years, but I thought at this conference in particular, there was a significant increase in activity in this domain. Shale, of course, isn't just a U.S. phenomena. It's a phenomena that's arising across the world and has led to some really interesting applications for our community. So we've covered the traditional terrain, and there's a whole new field of activity that our community has now been practicing in, and that's really wonderful to see in this conference. The PSE community has also had significant impact over its life, and certainly if you think of the tools, the product of our research that have actually had industrial impact, certainly flow sheeting systems are there, model predictive control is there, dynamic systems modeling, process integration and synthesis in general, and process planning and scheduling, to say nothing about real-time process optimization. So those have been areas where we can actually point to delivering value to the industry. It isn't just academic pursuits. So if we look at this accomplishment list, we can then go to what has transpired at this conference. And certainly, if you do, keyword, you'll find we've had plenty of discussion of product design, of process synthesis, of energy integration, of sustainability and life cycle analysis, which are relatively new sort of objectives for our community. Design under uncertainty was, in fact, the subject of the lead plenary of this conference. On the dynamics and control side, certainly control theory, plant-wide control, monitoring, estimation were covered, and then control of some specific families of unit operations, columns, batch operations, crystallization control. Among those, I would say that the area that has particularly seen emphasis at this meeting has been that of product design. Product design has not been a new topic for us. It's something that we've been pursuing for 20 years, but I was struck by the fact that at this meeting we really had quite a concentration. In fact, those of you that attended FOCAB-D a year or so ago, that concentration was much smaller. Here we had a very interesting plenary presented by Professor Ka-Eng. We've had at least 7 keynotes and some 30 individual contributions. Most of those contributions still pursued this sort of sequential approach to product design, which started off with identifying in various ways candidates for products, then selecting from those candidates, then conducting the process design activity, repeating that with the candidate list, and then choosing the best. However, in addition to that, I thought a really important contribution that emerged at this conference is really the beginnings of tools, that the user community can use, because we need these kinds of tools. Envision doing process engineering without flow sheeting packages. It really wouldn't have advanced very well. So we do need tools in addition to new concepts, and I thought there were at least several presentations of tools. Now, admittedly, the principal contributions were looking at blended products, but I think we've got some interesting work in terms of learnings on how to use molecular modeling tools to really help advance this domain. Of course, the target is really that of integrated product and process design, and one would hope that we would be able to systematically replace the sequential process with a simultaneous one. But there already are papers here and there which begin to do this simultaneous product and process design. So lots of good contributions here. Clearly a key area for PSE research going into the future. Now, if we look at additional sort of topics of scope here, certainly in the operations domain, if you look across the program of 500 papers, we've covered plant complex management. We've covered supply chain, planning, scheduling, intelligence systems. No one talked about dumb systems. We did talk about abnormal events. I guess normal events are not of interest either. And we did have some discussion of process safety. Integration was very much a topic. Indeed, a very nice presentation by Professor Epistokopoulos addressing, some aspects of design control integration, but also integrating from the supply chain down to the process unit, and of course this issue of product process design. On the tool side, we've covered significant advances in basically mathematical programming and optimization. Again, optimization of uncertainty, integration of CFD and population balances, estimation problems, of course, modeling and simulation in general. As you recall from the opening presentation from Professor Ghani, modeling and simulation is the largest sector among the contributions for the conference. And we had agent-based framework and some things under the category of cyber infrastructure, which were principally, I would say, some both data management and sort of advanced computer architecture applications. Now, the area that I found particularly interesting as a theme, which emerged more strongly at this conference, is that of really looking at supply chain as not a monolithic entity controlled by one central player, but the notion that there are really multiple interacting entities that drive a supply chain. And again, this is a topic that has emerged in prior meetings, but I thought it was notable at this conference that we really had a number of interesting contributions in this area. And one of them used the now well-established tool of agent-based model to really look at a fairly complicated supply chain. And that was a presentation that some of you may have heard on agent-based model of the German biodiesel supply chain, which when you look at the chart there basically has a number of agents in it, both farmers and process operations unit, distribution systems, the customers, and of course the governmental agencies that regulate the various transfers that occur. But there are other presentations that really use sort of game theoretic concepts. I thought it was kind of fitting. That's one of the contributors used the Nash pricing model, and unfortunately Dr. Nash passed away recently, but I thought it was fitting that someone had a very timely recognition of his impact on our community. But similarly, there are several other presentations that really dealt with the interaction between at least two entities, and either in terms of determining transfer prices or in terms of dealing with sharing of capacities. So I think this is really a very exciting area for the supply chain part of our community, and I hope that it continues to grow because it gets us a little bit closer to reality in terms of how companies currently have to operate. Now, there's a cast of characters that I want to introduce to you because the next phase of what I wanted to do is to go beyond sort of general categories, which I just did, to actual identifying individual papers that we thought were novel. And in order to achieve this, since this community contributed about 500 papers, I decided it was appropriate to launch a paper mining project. This is the equivalent of data mining, but it's on papers. And so I was happy to say that I was able to engage three colleagues, Carl Laird and Sultan Naj and Fenke and myself, to actually engage in this paper mining activity. And we used a range of techniques in order to do this. Of course, very sophisticated AI learning tools and innovation discovery methods. And then, of course, also some old traditional methods, which, even reading papers, and listening to presentations. So we were clearly used a collection of skills and tools in order to achieve this. And so we came up with a list of 12 papers. And this was a very scientifically put together list, so it is beyond question. Now, I've divided them into 4 categories. The first is design. One of the papers that you just may have heard earlier in the day today was Philip Lutz's presentation on process intensification, in which he really pulled together some of the essential elements that are involved in process intensification. There was a very nice application paper that was a joint contribution from AkzoNobel and academia that involved purification, really ethanol water purification, which is a classical problem using some interesting technology. And the third was a water resource management application by a team from Plapiqui in Argentina that addressed a really interesting problem, and that is of how to design and manage wetlands as a way of treating water resources. Now, of these 3, we really only have time to talk about one of them. So I just, will summarize for those of you that weren't at the presentation, the contributions in that paper. Basically, it addressed the problem of, purifying an ethanol water mixture created from biosourced material, and to do this in an energy efficient way, recognizing that the conventional sort of 3-column system that's used to get really high purity ethanol is known to be very energy inefficient. And so what they proposed is an innovative divided wall column design, which is interesting because there haven't really been that many applications in extractive distillation. So they really did extractive distillation. They also used vapor recompression and came up with a very interesting system that could also be called a process intensification, because it had really combined in one unit all 3 of those distillations. And by virtue of using vapor recompression and in addition a side reboiler, came up with a very efficient design. In fact, it's quite impressive that they're able to reduce the energy requirements by a substantial amount, from about 2 to 1.2. And that's really very much needed for the bioethanol, to really be a sustainable sort of product of biomass. And I thought this was really, I should say we collectively thought this was a very interesting example of how PSE can really solve practical problems, okay? Now, in the area of control, we really came up with, identified 3 contributions. One of these was the integration of design, control, and scheduling by the team led by our cross-Atlantic collaborator, Professor Pistakopoulos. Not only his main presentation, but there are 3 application papers that appeared in the program in various forms that really use this concept. There was also an interesting contribution. My name is there, but I assure you I had not much to do with it. It's really colleagues at the Polytechnic Institute in Milan that have put this concept together of really combining the design and control of a batch system. The third was the paper, but was given very capably by Professor Skogestad, which very elegantly summarized some systematic approach to plant-wide control. Now again, we really don't have the time for me to walk through all of these. I encourage you on the plane back to, if you haven't read this, read it, and then contact the authors for the full-length paper. But I'll just briefly summarize, borrowing from Professor Pistakopoulos, sort of the main contributions of this work. And I think, again, I like the fact that not only did the research group put together the intellectual ideas, but they actually deliver it into a form, which I'm sure he'll freely share with the entire community. All you have to do is send him an email, and he will let you download it from his Dropbox. But it's really an interesting toolkit, which is built around the theme of multi-parametric optimization, which Professor Pistakopoulos has pioneered over the years, but then also includes the capabilities of building rigorous simulation models. And I was really surprised to see GPROMs was used. I thought for sure they would use MATLAB or something like that, you know. Had a toolbox for producing reduced order models, of course the multi-parametric part, and then, you know, linking this together into potential MPC formulations, and then allowing, I thought a very nice concept of allowing this to be validated against the high fidelity model. So I think this is really a nice body of work, both conceptually and methodology and delivery, hopefully to the community in due course, and I'm sure Texas A&M will distribute it worldwide, no problem at all. Now, third category was that of operations, and again, there are three contributions that our team identified. The first was the duality-based approach to bi-level optimization, which is presented in the context of capacity expansion, but is really an important general concept. As I pointed out earlier, it really helps address some problems in this multi-participant supply chain environment, for example. There was a very nice summary paper by Professor Yu that really addressed the use of mixed integer fractional programming for a series of applications. And third, there was a paper on scenario-based price negotiation using game theory from the group at UPC. Again, I'll just pick one of those to summarize, and that's the contribution from Professor Yu's group. Essentially, the notion of a fractional program is allow one to address problems in which the objective function is really a ratio of rational functions, and it arises naturally. For example, if you're trying to do optimization of a batch process over cycle time, or if you're looking at maximizing return on investment, or, you know, life cycle optimization and so forth. And while the basic idea is really remarkably simple, when we convert the ratio into a parameterized function, and then deal with this parameterized function as an approach to optimizing the original objective function. Now, Professor Yu has, of course, addressed this problem for a few years now, but I think what we've discovered is that he's made some significant contributions here. First of all, in convergence conditions that show that you don't have to solve this effectively root finding problem to optimality. You can do it approximately, which saves a lot of computation time, but then also addressing the issue of global optimization. So this is really, again, a piece of work that sort of not only further develops the methodology, but also expands the range of applications. Then we go to the optimization numerics world. And again, one of the really interesting contributions was that from Professor Ageman's group. They really looked at, identifying transition states and using that as a vehicle within global optimization. A really very important contribution in advancing, I think, global optimization. There was a use of GPU units to accelerate computations, the difficult computations involving population balance computations. And then a third contribution, which was really introduced a dynamic method for computing thermodynamic equilibrium process simulation. And this paper actually appeared in as a poster paper. And I'm not sure how many of you managed to find that paper, but I think it's a very neat concept. And so wanted to spend a little bit of time featuring it. So the basic idea is really how to improve the efficiency, reliability, phase and reaction equilibrium computations, which typically are nested within simulations. And so the goal of this work was to really try to improve the reliability of those computations, because the free energy minimization is typically handled as solution of the optimality conditions. So you're converting it to a set of nonlinear equations. The phase equilibrium, likewise, since you're simply equating free energy, you essentially end up nonlinear equation solving, and we all know nonlinear equation solving typically has difficulties with initial values and with convergence. And so the idea that the group proposed is really a pretty old one. At least, you know, it's been around as long as I have. But I thought the application of it is quite nice. And so the idea is to take this equation solving problem with unreliable convergence and turning it into integrating a set of ODEs. And then, of course, the trick is how do you convert those ODEs into something that's reliably solved, and that they did by formulating this appropriately and then making sure that, you know, second law isn't violated and all that sort of stuff. Now, the advantages, as I mentioned, was less sensitivity initial estimate, more reliable solution by taking advantage of efficient integration tools, and also the possibility of really allowing a combination of these calculations, phase and reaction equilibrium, to be carried out. So really a classical method has been used in other settings, applied to a problem that hopefully will have impact in simulation. So having gone through these 12 featured papers, the last phase of what I wanted to do is focus a little bit more on things that we thought needed more attention, and then finish off with some directions for future research. And certainly the one area that keeps requiring attention from our community is that of safety and design for safe operations. It's been talked about in our community for a long time. We have been encouraged to do things in this area, but it seems like the progress has been relatively slow. But at this meeting, there were 7 papers that addressed various aspects of process safety. For example, there was an interesting contribution from Rio that talked about, you know, incorporating safety in the design of a control system. So how to test the control system for failures and taking preventative action. There was an interesting contribution from our host institution that looked at how to integrate safety considerations in the workflow associated with design. And then there was an interesting presentation given by Professor Srinivasan from IIT that really focused on an aspect of process safety that really, to my mind, hasn't gotten all that much attention in our literature in the past, and that is really the human factors. And I was struck by the fact that Raj was pointing to the fact that many of the major accidents that have occurred have actually been because of human failure. And certainly the recent train wreck outside of Philadelphia was another example of really human failure, the operator simply going too fast. So I think you know, we had some interesting cases that were presented here, and I think the message here is we're making progress, but we really need to move a lot faster, because safety, it seems to me you can't talk about life cycle and sustainability and not really deal with safety squarely from design through operations. Okay, so that's an area that needs more attention. Another area that needs more attention, and I guess I'm sort of harping on this subject that repeatedly, is we really haven't done enough to really take advantage of advanced computer architectures. And you know, there is no better example than those of you that may have read the history of developments of CPLEX over the years, where yes, since that software has been used, computing has improved, but actually it's the algorithmic improvements, the cuts and the various heuristics that are built into it that really account for most of the improvements in the size of problems we're able to address. So, I mean, that suggests to me we really need to invest more in this area. And there's certainly been at least 3 papers, but that's a relatively small number out of some 500 that address aspects of it. And one of those papers was from the group by Professor Naj, where they really looked at GPUs, but there was another GPU-oriented paper on the program. I won't go into the details. The main point here is that this is an example of a computer architecture that's relatively cheap, and the comparison that was made here was essentially to do, I thought it was an interesting idea. They're comparing the computing power for the same cost of hardware. So not looking at, speed up based in terms of number of processors, but if you spend X number of dollars on computing hardware, what can you achieve by running this operation? And they got some pretty substantial gains, really up to 35, which takes the application which this was intended for and allows it to be moved in the real-time domain. Okay, so the original application was one of really doing nonlinear model predictive control. Okay. So there's lots of opportunities, seems to me, in this area. Certainly, the more we can do in real time, whether it's for control or it's diagnostics or monitoring, computation will help. There's been lots of developments, I'm sure, at all of your universities in using advanced architectures. And really, we have a very minor community that's actually focusing on the algorithm engineering to take advantage of that. Okay. And there are a couple of those apostles in the audience, so I won't embarrass them by asking them to stand up and having you applaud them. But I think it's a very important effort for us. So if we look in the future, definitely integrated approaches to process safety have to be high on the list. Using advanced computing architectures has to be very high on the list. And then there's 3 other topics that I would call your attention to. We've already had discussions just today on process intensification, data and knowledge management, and multi-scale modeling are the other 3 that I would just take a few minutes to describe. The first of these is the intensification topic, and very conveniently, Professor Lutze had a presentation earlier today. So all I really have to point out to you is that intensification has pluses and it has minuses. And the pluses are, of course, the reduction in complexity in terms of the number of distinct equipment items that have to be used. And that in itself offers some gains in safety and cost and so forth. It does have some minuses in that you reduce the degree of freedom and control becomes more complicated. But this is something our control community always applauds because it's not interesting to do control research if control isn't complex. But that's the trade-off. Of course, there have been examples of continued baffled crystallizers and reactors and divided wall columns and so forth. But the challenges there are, again, those of modeling, of dealing with more complex systems. Inherently, there is, of course, intensification, pathway identification required. And, of course, the really interesting subject, which Professor Lutze touched, I guess Dr. Lutze now, if I recall his slide, he's migrated to a company, is really going back to synthesis based on phenomena rather than synthesis based on existing hardware. And I thought there have been several people that have raised this issue, and it was good to have it raised again. I really do think it's a very important area. And indeed, we need to do some work because there really hasn't been that much adoption in industry. you know, the problem with, it's often said that, for example, microreactors are wonderful because scale up is just numbering up. But of course, when you number up, you lose economy of scale. So, you know, you have to make a good case for it. It has challenges in terms of, you know, having to consider the whole thing at once, and that's not always possible, okay? Fortunately, Dr. Burka championed a workshop that the NSF conducted earlier early in fall 2014. It was led by Professor Ira Petritu and Baldea. They really looked at the research potential in this area and really identified a number of opportunities where process intensification could really have impact. I'm not sure whether that report is out yet, is it? So I would encourage you to go to the NSF website and take a look at it. I thought it was a really very timely that this topic received some attention. Okay, and I think it's a very productive area for our community because, as I pointed out earlier, it requires integration and it requires a careful look at how you do control. The big data subject we all are aware of. We get inundated with information about that, and certainly characteristics that are described in the public literature as, you know, big data is big data because of the volume of information, the speed at which it is generated, and the variety at which it is generated. And it's generally viewed to be unstructured data. And really, our community loves structure. So perhaps we can take advantage of what's going on in this field and add our ability to structure it. And actually, at this conference, we did have some contributions in this domain. Certainly a very interesting presentation by Professor Zhao from Tsinghua University, where he describes some of the activities that he is doing with the major companies in China that involved really extracting abnormal situation management information from plant data. And I think that's actually a topic that also Professor Cedar attacked a few years back. But it needs more effort than just a couple of Lone Rangers. So I think it's an important area. We've also had some number of contributions in the order of 4 or 5 papers that worked on the notion of using ontologies essentially to create a framework that allows data to be better structured and then searchable. I didn't really enumerate those because there was actually a specific session that you can look to that had 4 papers in itself on ontology. So what are some of the opportunities? Well, we certainly have data sources. You know, there is no question but that process historians are enormous sources of information. As Professor Zhao pointed out, a typical FCCU unit generates on the order of 1 terabyte of data from all of the online sensors per year. So generating lots of data is not a problem, and that's just one process unit. There are other sources of such information. People are now actually recording transactional data in supply chains. There's lots of information associated with the process of product and process development that really needs structuring and mining. Certainly, if you even think of the kinds of tools that we use and the data that's generated from them, that's valuable in addition just the final solution that we report, large sources of information. And of course, consumer products is another area. So for our community, potential applications, of course, are in real time. I mentioned product process development support. Engineering-wide decision processes require lots of information at different levels. And everyone in the industrial community that you talk to, they all want to somehow be able to extract knowledge and find better ways of doing things from the massive knowledge that are generated internally, but most of that knowledge is internalized in the heads of a few people. Okay, so there's definitely applications there, and certainly intelligent alarm management, abnormal situation management is there. If you had the right data, you could predict when an abnormal event is likely to occur, when maintenance may be needed, and actually then really streamline operations. Certainly, big data like this can serve as providing actual numerical, quantifiable probability information that can be incorporated into a quantitative risk assessment, which is, again, something that our industrial colleagues are always talking about, and certainly in the pharma industry is a big area of focus. And finally, the last thing I wanted to touch on was really the multi-scale problem. We've been talking about this subject for a long time. This is a diagram that I think I can attribute to Professor Marquardt some dozen years ago, which had length and time and listed the scales from molecular to enterprise level. So we've talked about it. We certainly have talked about the need for multi-scale in terms of linking planning, scheduling, RTO, and control problems. And certainly in a lot of our product design, and this is sort of the scale that's involved in a pharmaceutical product, where you go from molecule to crystals to aggregates of these particles to blending of particles of different types to compacts in which these particles are compressed to tablets which you take. And of course, at the end, there is a performance that has to be met in terms of benefit to the patient. This clearly goes from the molecular all the way to the patient delivery scale, and we really don't at present have any way of linking those kinds of scales. So the challenge is, can we do more than link two at a time? Because that's about as far as we've gotten. Certainly the classical strategies we've used are those of passing parameters from a lower level to use in the model at the next level up. And then if there's a mismatch, to try to fix that. Certainly in the planning, scheduling, control domain, we use the old rolling horizon approach, in which the early parts of the horizon we discretize more finely, whether it's for scheduling or control. So those we've had for a long time. But those are typically sequential approaches, and the real question is, how can we couple this? How can we do this ideally in a simultaneous fashion? How could we actually, instead of passing parameters, actually generate meaningful surrogate models? And certainly approaches like the multi-parametric approach that Professor Pistakopoulos has advanced is really one way of aggregating information into a surrogate that you use directly. So you don't have to resolve the problem at that level. But this is, I think, really a major problem, and if a computing community like ours can do it, who can do it better? Okay. So I'm sure this is not something we'll solve in a year or in a day. It's been around for a while. But I think the kinds of computing power that we now have, we really should be able to creatively address and go beyond 2, 3, 4 levels, each year another target. Okay. So with that, I'd kind of like to summarize. What I've tried to do is to, first of all, remind you that the PSE community does have a pretty substantial legacy of actual contributions that have led to industry practice. Certainly the emphasis on societal needs driven by the needs for energy and sustainability have really opened up a whole series of unique opportunities for us, whether it's in renewables and CO2 management, shale, so on. Of course, I had to list the water, energy, food nexus. It's just a buzzword that has to be listed on the slide. But it is an important issue in that it reminds us of the fact that these things are so tightly linked that we and again, it's an integration problem that our community can address. PSE methodologies are the right methodologies to address these problems, I feel. Okay. There is, of course, again, opportunities for exploiting advances in computing architectures and data and knowledge management and the multi-scale part. So it isn't just applications, we also need to push forward on tools. Certainly this meeting, I believe, has been of historic scale, both the number of papers and the entertainment we've had, the amount of food we've consumed, and of course intellectual as well, you know, and the technical quality, I think overall, I'm sure you'll agree, has really been quite high, really. It's a pity that one needs to have a 50% paper rejection rate to get quality, but perhaps that's the only way to drive progress. Certainly, this meeting has set an enormous challenge for the next PSE. But fortunately, we have a team for the next PSE that is more than prepared to meet the challenge. Particularly, I can't imagine now that the team leader is in the Texas institution that it won't be bigger and better and, you know, and so forth. But you'll hear about that shortly. Certainly, we have to congratulate the organizers of this conference and really thank them. And you know, it's an interesting triumvirate because Professor Ghani is leading the charge, but we have a couple of important supporting elements that, in their own low-key approach, have really been very important in the organization. And I certainly want to give them credit. I couldn't collect the photos of all of the students and staff members that were also there because, you know, that's probably impossible to do given the number. But certainly, I'd like to ask you to join me in giving them a round of applause for their really outstanding effort. Where's the other guys? Okay. Well, with that, I think I've completed my assignment, and I'll turn it back to you to wrap up.
Okay, so I would like you to join me now to thank Rex for his very nice overview. And also a little present from Denmark. Thank you very much. So now we are coming really towards the end, and the next is two presentations by the two next conferences that you will be attending. And the first one is ESCAPE26 in Slovenia, to be given by Professor Kravania. You have your...
Thank you. Thank you very much for this opportunity. Good afternoon, ladies and gentlemen, dear colleagues. It's my pleasure to invite you to the next ESCAPE conference, the 26th conference, European Symposium on Computer-Aided Process Engineering, that is going to be held next year in the second week of June in Portorož, Slovenia. The main objective, of course, is to share the most current advances in the area, and I expect that significant number of attendees will get together, all from academic institution, research institution, and industry. And the other objective is actually also to enjoy Slovenia culture and nature heritage. topics that were selected are the following one. The first one is dedicated to process product synthesis, design, and integration. Topic number 2 is modeling, numerical analysis, simulation, and optimization. 3, process operation and control. 4, green bioprocess engineering and advances in biomedical engineering. 5, CAPE PSE in environmental engineering. 6, CAPE PSE in sustainable energy application. 7, CAPE PSE application. And 8, which is also very important, education related to CAPE and PSE. You should start already thinking about what to put in abstract, because the deadline is closing, it is approaching, is 1st of September. You can get all the updated information on the website, ESCAPE25 UMSI. Plenary speakers have been already selected and invited. You can see them: Adizazi Pagic, Anna Barbosa Pova, Herman Faise, Rafi Kulgani, Iri Klemes, Nick Sahinidis, Jean-Marc Leland. There are going to be many oral and poster presentations, and of course also some several keynote presentations. Publications: we are going to have electronic proceedings in computer-aided chemical engineering, book of abstract, and those the most, let's say, the best contribution will be invited as extended papers to be published in a special issue of Computer and Chemical Engineering. There are going to be 3 major events, social events. First is get-together party on Sunday. Then, if the weather will be good, and I think it will be, a boat trip from Piran, from the place, to another city, Koper. And we are going to be guided to visit a wine cellar there. And then gala dinner as usual. And several excursions will be also provided. Fees, normal fees as usual. Should say that just after ESCAPE conference there is going to be another conference which is called Southeast Europe Conference on Sustainable Development of Energy, Water and Environmental Systems. So this is again very related to PSE, and also ECOS, a conference dedicated to efficiency, cost optimization, simulation, and environmental impact of energy systems. The venue is the northeast part of the Adriatic Sea. Adriatic Sea is this one here, and this venue is going to be at the seaside, southern part of Slovenia. There are some very nice small cities there. Trieste is also very close. You can drive by hydroglider to Venice also. Probably the most closest airport is Trieste airport, then Ljubljana, 1 hour and something. Probably even Zagreb could be possible. Venice also is possible to use as a port. The venue is going to be in a very luxury hotel, Bernardin. Bernardin Group actually has 10 hotels, 5 apartment dependencies with self-catering and so on. This is the main hotel where the conference is going to be organized. It has a number of very luxury hotel rooms and so on, with very nice spa. You are invited to be there. Very close to that hotel, I would say 1 minute or so, there is a 4-star hotel, Histrion, and 3-star hotel, Ville Park. Let us look at the conventional center. It has a nice view on the sea at the evening. And if you don't know yet whether you will come or not, please look at the video. I don't know why there is no sound. Okay. The music is Tartinius music, the composer which was born in that part of the world. This is located very close to our venue. Lipizzaner are originated from that area, not from Spain or US. It was in one movie, but it was wrong. I'm sure there will be a lot of possibility to share science with different kind of pleasures. By that, I'm finishing. I would like to warmly invite you to Slovenia to next ESCAPE meeting, and see you there. Thank you very much.
So remember that 1st of September, the deadline of submitting your abstracts. And this is a hard deadline.
Yes. First of all, I would like to express personal thanks to Professor Gani for the truly outstanding conference that he has organized in terms of the facilities, the selection, the quality of the papers, and of course the dinner event that was spectacular last evening, that also received the quote by Professor Reklaitis about the challenge for the organizers for the next meeting. I can tell you, after consultation with Ignacio Grossman, that in order to compete in the United States with such a spectacular dinner event, we have to move the location from the beautiful San Diego to Las Vegas. And given that I have no intention to perform such a move, I would like to focus on the exciting, aspects of organizing the Process Systems Engineering 2018 in the beautiful and sunny city of San Diego. So with that in mind, the first point that I would like to bring to your attention, that it is going to be held July the 1st through July the 5th. It is a similar format that we have seen actually in this meeting, but it has a distance in time that is 3 years from now. So here is a picture, and of course underneath it you have the website, the URL address. It is an active website that you can all check and find out information about it. So first of all, I would like to extend you a cordial invitation to participate. The thing that Gavin Towler and myself can promise, that it's going to be a very high quality that will definitely rival the quality of this meeting or any of the PSE meetings that have been held so far. It is going to cover the subjects of PSE that have been throughout classified as core or cross-cutting subjects. We're going to see exciting developments, since it is a triennial event in the different areas. Some of these areas have been outlined actually in the summary of Professor Reklaitis, but we will not classify them as buzzwords. Energy, water, and food nexus is not a buzzword. It is actually a reality. It is a very important actually synergy that needs to be created in the boundaries of all of these three, and it's very important to highlight it as such and to pursue it very vigorously. So in regard to the structure, we're going to have, of course, plenary lectures, we're going to have keynote lectures, we're going to be restrained in the number of plenary and keynote lectures so as to justify their value. We're going to have oral presentations. We're also going to have short oral presentations, like the format that Professor Gani followed, 5 minutes, so as to represent the key contributions of the posters. And of course, we're going to have a very vibrant poster set of presentations. We would like to see people from academia, industry, and government participate in all fronts of those events. And now coming into the themes that we're going to discuss. We're going to have core themes starting from traditional areas like process and product design and synthesis. We have seen a lot of activities in this conference. We're going to look into the process dynamics and control, again, a lot of activities, scheduling, planning, supply chain and uncertainty, and all the interactions and integrative components, integration of process operations and design and synthesis, modeling, analysis and simulation that requires actually a lot of, or has attracted a lot of interest here, but also optimization methods and applications. So these being the core components, we have to think also about additional themes that will really be cross-cutting themes across all of those areas. So I have at the very right in this slide, energy, water and sustainable environment. We have biological and biomedical systems engineering. So we have to possibly look into applications that will go into computational biology, but also biomedical applications. Molecular and material systems engineering, we have to enhance the boundaries of process systems engineering that will provide interactions with the discovery of the materials That's a very important area that we need to address so as to address grand challenge problems in the 21st century. Multi-scale systems engineering, definitely we have a lot of core components and application components already in place, but we need to further enhance. Smart manufacturing and novel supply chains. And yes, big data systems analysis. We are being flooded with data, we have not exploited properly. It's not just actually the selection of very large data, it's the identification of the key features that interpret those data. How do we come up with methods and analysis and techniques that are computationally efficient to achieve this goal? Man-machine interface systems engineering and also safety-driven systems engineering. I think as process systems engineers, we have a responsibility to introduce some rigorous methods in trying to analyze and hopefully prevent issues related to safety. Now, these are the themes that you are going to see in the pamphlet, you're going to see on the website, but please note at the very bottom these descriptions, topics not covered above, and emerging, because we have a 3-year time horizon, will also be welcome to be components of the Process Systems Engineering 2018. The organization consists of my co-chair, Gavin Towler, who is the CTO of UOP, and myself. We have a local organizing committee, and Professor Pistikopoulos also will be part of that. An international committee that is currently work in progress. And yes, we have some specific dates. I know you don't want to think for more than a year, but just 2017, September 1, will be the deadline for the abstract submission. The publication policy will be pretty much similar to what Professor Gani has followed for the PSE 2015. That is, we're going to have from Elsevier a specific set of volumes or electronic actually versions, and possibly 1 or 2 special issues from computers and chemical engineering. And in this last slide, I have depicted 2 components. The component that you see on the very left is the San Diego, the city of San Diego, one picture of the city of San Diego. And the second component on the right is where we're going to have the venue of the conference, which is the Manchester Grand Hyatt Hotel. So I have, as a subsequent actually part of this presentation, 2 movies, one for the conference venue and the second for the city of San Diego. So I'm going to start first with the venue. I would like also to mention that the venue for the conference is only 5 minutes from the international airport for those who are going to actually travel from abroad. And the second movie corresponds...
My San Diego is home, my San Diego is beaches, and my San Diego is community. One of the great things about visiting San Diego is our climate. We're a perfect 70 degrees, and it does make people extremely happy. It's close to our beaches, it's close to the mountains, it's close to another country. That's what makes San Diego a great destination. The coastline goes from urban to upscale. It has something for everybody to enjoy, from surfing to kayaking, rowing, paddleboarding, windsurfing. The San Diego Bay is home of the Seaport Village, the USS Midway Aircraft Carrier Museum. You can also take harbor cruises around the San Diego Bay. San Diego has a lot of family-friendly attractions, number one being the San Diego Zoo. Legoland is a great place to visit with children. Be creative, great ride. Mission Bay is probably known for SeaWorld San Diego, which is home to Shamu, as well as penguins and polar bears. Balboa Park is where most of our museums are located, and also our beautiful gardens. San Diego is consistent of very many diverse neighborhoods through the downtown area, East Village, La Jolla. Old Town is a majestic walk into our past. You can walk down San Diego Avenue and see the ladies making tortillas. Everything is very authentic. The Gaslamp Quarter is where San Diego nightlife lives. Anyone can walk down the streets and find cafes to diners to nightclubs. San Diego's pristine beaches, warm climate, and countless activities attract guests year-round. I look forward to your visit to my San Diego.
This concludes the presentation, and I would like to extend again a cordial invitation to participate vigorously to the 3-year event that is forthcoming, that is July the 1st to July the 5th of 2018, that is the Process Systems Engineering 2018. Thank you for your attention.
So thank you very much, both Professor Cravagna and Professor Fludas, for the presentations of your conferences. I hope to see all of you in both the conferences. And now I'll just have the final slides, and then we can have the coffee, tea, and goodbye. So all of you have praised the conference organization very much. It was a team effort, not just me. A lot of people did a lot of work. And I don't have the picture of all of the people here, but I would like all the volunteers who are in the room, please stand up so we can always all recognize you and thank you. Please. All the volunteers. And also, of course, my faculty colleagues have helped, and they will also have some work to do for the special issue that will be made. I would also like to thank all the session chairs, the presenters, plenary, oral, poster. Once everybody had come, I thought, okay, I didn't have to do much because the conference will run by itself. The session chairs will go to the sessions, the presenters will go there, and everything would run, and actually it did. So that was very nice. Thank you all for maintaining the program and helping us with the program. So let's thank all the speakers and everybody also. And also I would like to thank the Bela Center, that is the conference center here. 2 people who are our contact persons, Admira and Linda, and of course the technicians in all the rooms who had made sure that all the facilities were working almost perfectly. And thank you very much for all the help and facilities that you have provided. Thank you. And some final announcements. If you have not already received email by now,